Now we are going to learn about a new chapter, relations and functions. So this is the first chapter in 12th standard. Before this, we have to know two important definitions. One is set and another one is Cartesian product. Okay. Earlier, you studied both set and Cartesian product in class 11. But once again, we recap these two definitions. So let us see set. What is a set? A set means it is the collection of a well-defined objects. For example, collection of alphabets A, B, C, D and so on up to Z is a set. Let it be some letter A. And the collection of the numbers 1, 2, 3, 4 and so on. Let it be some B. Now this is also a set. So these are two examples to a set. Now we know that if suppose the number of elements in any set is finite, then that is called a finite set. The number of elements in any set is infinite, then that is called infinite set. Look, A has a limited number of elements, A, B, C, D and so on up to Z, probably 26 elements there. Therefore, the number of elements in the set A is equal to 26, hence it is a finite set. Whereas, the set B contains infinitely many numbers, 1, 2, 3, 4 and so on, it is going on. So that this set contains infinitely many numbers, hence it is a infinite set. And a set which does not contain any element is called empty set. It is called empty set. Usually it is denoted by 5. So it is empty set. A set which is not empty, that is called non-empty set. That means the set may contains whether a finite number of elements or infinite number of elements. Then that is called a non-empty set. The next second definition is Cartesian product. Cartesian product. What is this Cartesian product? Let us take the two sets, non-empty sets probably. Let A comma B be two non-empty sets. Two non-empty sets. And for suppose some element A belongs to A and some element B belongs to B, then A is related to B, like A comma B, is called ordered pair. Is called ordered pair. So here A is some element chosen from A and B is some element taken from B. Now the pair A comma B is called ordered pair, and the collection of all possible ordered pairs defined from A to B is called Cartesian product. So the collection of all possible ordered pairs. So I am taking in set builder form like this. The collection of the ordered pairs where A belongs to A and B belongs to B. Now it is a set collection of all possible ordered pairs defined from A to B is known as a Cartesian product, which is denoted by A cross B. So A cross B is a Cartesian product defined from A to B and it is collection of all possible ordered pairs defined from A to B. Now let us take one example. Suppose the set A is equal to A, B, C and another set B is equal to 1, 2, 3. Now we can make a possible ordered pairs from these two sets A comma 1, A comma 2, B comma 1, B comma 2, A comma 3, of course, B comma 3, and C comma 1, C2, C3. Now these are the possible ordered pairs that are defined from A to B. Hence, this is a set known as Cartesian product A cross B. Now this is one example. Now let us take one more example. In a combined family, let A is equal to a set of males. Of course, let they be A1, A2, A3. And B is equal to a set of female, that is equal to B1, B2, B3. A is set of males and B is set of females in a combined family. Now again two sets are chosen. Now A can relate with B1. Definitely A has some relation with B1 and A1, B2, A1, B3, A2, B1, A2, B2, A2, B3. Like that A3 also has relation with B1, B2, B3. So that the possible number of relatives A is equal to a set of males A1, A2, A3. B is equal to set of females B1, B2, B3. Now the possible relations between A and B. A cross B is equal to, the possible ordered pairs are A1, B1, A1, B2, A1, B3 and also A2, B1, A2, B2, A2, B3. Next with A3, A3, B1, A3, B2, A3, B3. Now, therefore, it is the set of all possible ordered pairs defined from A to B is known as a Cartesian product. Now, here A1 is related with B. A1 is related with B. Now, that is the connection between the two objects AB. Now, this type of connection is known as a relation. So, relation means it is nothing but a relation between the two objects, a connection between the two objects. Now, relation. Now, let us define relation. Any subset of a Cartesian product is called a relation. So, this is the mathematical definition. Any subset of a Cartesian product. Suppose, let us take two non-empty sets A and B. A is equal to A, B, C and B is another non-empty set 1, 2, 3. Okay. Now, we have the possible ordered pairs from A to B known as Cartesian product A comma 1, A comma 2, A comma 3, B comma 1, B comma 2, B comma 3 and C comma 1, C2, C3. Now, these are the possible ordered pairs defined from A to B known as a Cartesian product, already you know. Now, I am taking one set like this A comma 1, B comma 2, C comma 3. So if we take a set be like this, A1, B2, C3. Now this is a subset of the given Cartesian product A cross B. You know, it is a subset of, because of these ordered pairs already belongs to the set A cross B. Hence, it is a relation denoted by R. Similarly, let us take one more subset like A1, A2, B2, C3 like this. See here, it is also a subset of A cross B. Hence, it is also another relation. Suppose for the first one be R1 and it is R2, etc. We can define some other relations from A to B. Now, take one more example. Let us take one more example. Let R is equal to modulus of x minus y is equal to 2 for some x belongs to A, y belongs to B, where A is equal to 1, 2, 3, 4 and B is equal to again the same set 1, 2, 3, 4. Now, let us check whether this R is equal to modulus of x minus y is equal to such that x belongs to A, y belongs to B is a relation or not. Let us check. Actually, here we have there are 1, 1, 1, 2, 1, 3, 1, 4 like that. We can define 4 into 4, 16 ordered pairs can be defined. Now, let us see. Modulus of A cross B is modulus of x minus y is equal to 2. What are the possible values that are satisfying this condition? Suppose if we choose 1 from set A and 1 from set B, 1 minus 1 is equal to 0 but not equals to 2. 1 minus 2, no. 1 minus 3, yes. Minus 2, of course it is modulus, so that it is equals to 2. So that the possible ordered pair satisfying this condition is 1 comma 3. Okay. Next, any more? 1 comma 4, not possible. And 2, 2, 2, 3, 2, 4, yes, the second one, 2, 4. Because 2 minus 4 again satisfied the same. With respect to 3, 3, 1, 3, 2, no, 3, 3, 3, 1, okay, possible na? 3, 1, yes, it's possible. 3 minus 1 is equal to 2. So, 3, 3. Next, with respect to 4, 4 comma 2. You know, this is a subset to the Cartesian product defined from A to B. Hence, this R is a relation. This is a relation. So, we can conclude that the relation is always, relation R is always subset of A cross B. Relation R is always a subset of A cross B. Of course, sometimes R may be equal to A cross B. Therefore, finally, R is subset or equal to A cross B.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.